Hi all, welcome to day 12 of Advent of Elixir. Today we're going to take a look at the peer module. This is a new Erlang module as of Erlang OTP 25. The peer module lets you start up a second Beam virtual machine alongside the one you're in right now. It's designed to help you test code that relies on clustering. So instead of having to guess if the clustering you've implemented works, you can know for sure. So peer mostly exists to replace the slave module, which, aside from being somewhat unfortunately named, has fewer goodies. So I'm going to show you some very basics of how to use the peer module and what happens when you run it. So on the right hand side, I'm going to run a ps command, which will tell me which Beam processes are running. And as you can see, when I run it without having any Beam running in my console, I get no results. This is just the grep command. And so let's go ahead and start our Elixir instance. So here I'm going to just do IEX smix. I'm going to provide a cookie cook and an sname, which is a short name, main. So I'm going to run that. You can see that my Elixir is running in distributed capable mode. And if we run the psaux command, we're going to see that now we have one Beam process, operating system process running. So great. Now let's run peer.start, which is the function that you run to get a peer node running. At a bare minimum, I recommend providing the connection and the name to get things up and going. So let's see what that looks like. Peer.start, connection, 0 name peer. So the name parameter will set the sname of the peer node that's going to get created. And this connection parameter tells you what channel the peer module system will use to communicate with the peer node. In this case, you can provide a TCP/IP port, and the port 0 by convention means just pick some port that's free, that the operating system knows is not being sit on by some other process in our system. So I think that's the safest thing to do, so let's go ahead and attempt to start that. And you can see this is the response. I'm going to clear this side, and then we're going to run psaux again. And now you can see that there are two processes that are Beam processes running. This one up top is the main Beam node, and this one is the peer Beam node. Okay. But they aren't connected. So if I run node.list, you'll see that there is nothing in that list. So let's connect these two virtual machines. Before we do that, I'm going to pull some variables off of the previous result. So OK peer and peer name is going to be assigned to v1. So that is the result from the IEX invocation in command prompt number 1. Okay, so the peer variable is set to PID. The PID and peer name is set to the atom of the peer. Great. Let's go ahead and try and connect this. So we're going to do node.connect peer name. And you can see this doesn't work. The result is false, and we get an error report saying the connection attempt was rejected. And why is this happening? This is happening because this peer node over here doesn't have the cookie set to cook, which is what we need to do. So what we need to effectively do is reach into the peer node and execute a command that will set its cookie. There is an Erlang command that does this. It's called erlang.setCookie. And so let's go ahead and run this. So to do that, we're going to use the peer.call functionality. We're going to call the peer, and then we're going to the peer PID. The PID can be thought of as a communications channel that wraps that TCP/IP port that got randomly picked by the operating system. We're going to call Erlang, the Erlang module, we're going to call setCookie function, and we're going to pass it the parameter cook. That is going to give us true, and note that this is roughly the equivalent of calling this. With the parameters being in a list. Now that we've done this, we can connect to our peer, and you can see it gives a result of true, and if we do node.list, it's also going to be give us the correct value. Okay. Suppose I want to run a different command on the remote node now that these are connected. I don't have to use the peer.call. I can use the more traditional rpc.call. And the parameters are the same, except instead of taking the peer PID, it's going to take the peer name. So for example, let's look at binary to atom. And then we're going to do foo. And that gives us the atom foo. And this is exactly the same as it. This is roughly the same as if I were to have called erlang.binary to atom foo locally, except of course that function was run on the remote node, and the result was sent back to me on this node. But you kind of you kind of have to take my word for it, because there isn't really anything distinguishing these two results. So let's run something that will be different between the two nodes. And so what I'm going to do is I'm going to store a value in the application environment of the remote node. So let's do this. rpc.call peer name application, and we're going to do the setEnd or getEnd function. This is equivalent to looking up the application environment variables for the Advent application, and we're going to just make up some environment variable called token. So this is undefined. We can then go ahead and set the env using the application.setEnv function, and let's make that the value 1, 2, 3, 4. And then after we do that and we try to get it again, we get 1, 2, 3, 4. Now, this is a remote operation. How do I know that it is? If I try to run application.getEnv, then we're going to, advent token, we're going to see that it's still undefined on this node. So on the main node, this application environment variable is not set, and on the remote node, it's set to 1, 2, 3, 4. So now you can see the difference between the two. Now, what's the difference between rpc.call and peer.call? Aside from the fact that, of course, peer.call takes the peer PID, communications PID, and RPC takes the peer name atom. Well, they're going to give you the same result, right? But the way to remember is that the peer.call functions use that side channel that we created in the very beginning. And the rpc.call requires the fully connected Erlang mesh that we created. So it's running on a different communications layer that got created when we ran node.connect. So one thing you might think to do is let's go ahead and node.disconnect. And then try and run the peer.call. And what we find is that if we do that, it still works. And that's because Erlang distribution networks we should run the rpc.call, and we still get the correct result. And that's because Erlang distribution networks are self-healing. So when it didn't see that node in its list, what it then attempted to do was to attempt to reheal the network, which it was successfully able to do. So, okay, that's not super helpful for us because we kind of do want to see what happens when we try to communicate and the network is down. So one way we can do that is we can again run a command on the peer node that makes it so that it will never be able to communicate back with the current node, and that will do a very good job of simulating a net split. So how do we simulate a net split? Well, what we're going to do is we're going to call the Erlang set cookie again and set it to something different. And we're going to set it to something different. And now we're going to do a disconnect. And now when we try to do RPC call, you can see the connection attempt was rejected, and we get a node down response. And so this is a somewhat effective way of showing that you can, yes, indeed, create a net split between the two. Of course, the peer.call function still works, right? And this will still give me the expected response from running this code on the running the application.getM function on the other side. Now let's go ahead and heal it by doing peer.call Erlang set cookie. Back to the cookie that we originally had, and then when we do an RPC call, and then when we do the RPC.call for the getting of the application getEnv, we get the expected result. So this is how we can break and heal Erlang networks using RPC and peer. So one question you may have is why I didn't use the application.getEnv function with a capital A, which would be the Elixir module. Well, if we try to do that, we're going to get this bad RPC exit error with an undefined application.getEnv response. And that's because the peer node only knows how to create the minimal Erlang distribution on the other side. And Elixir is not part of the minimal Erlang standard distribution. So it doesn't have access to any of the Elixir code because it doesn't know that that's something that it should be running. Okay, that is definitely a situation that is solvable, but I won't be going over that in this video. In the comments or in the description of this video, I'm going to go ahead and send you links to the peer documentation for the Erlang peer module and documentation for the Erlang RPC module. And I will see you tomorrow with more content.